Hi everyone, Tarulli Tutoring here. Today I'm going to go over grade 12 advanced functions concept of trigonometric identities. Alright, so let's start off by defining an identity and talking about why it's different from an equation. So, if we have an identity, this is something that is true for all values of the variable. Whereas if we have an equation, this is something that is true for certain values of the variable. So an example of this is if we have sine squared x plus cosine squared x equals 1. This is an identity. This is true for all values of x. Whereas if we have something like sine squared x equals 4, this is an equation. This is only true for certain values of x. Okay, so now let's look at some rules for proving identities. First rule is the left side, which I abbreviate with LS, and the right side, that's abbreviated with RS, must not be mixed up. That means I can't take a term that's on the right side and move it over to the left side, or multiply the right side by a value that's on the left. I can't do any of that. We've got to keep each side the same. They're two separate things. And generally speaking, we want to simplify the complex side. Sometimes there is an exception to this, because almost all rules have exceptions sometimes. But in this case, we just want to simplify the complex sides, usually. Okay, other cases, when we don't want to simplify complex sides, we have to simplify both sides. It's a little more annoying when this happens, but it does arise. And lastly, something that I find useful is that we want to change items that are written as in terms of sign. Or let me rephrase this. We want to change items that are written in things like tan x, cotangent x, secant x, and cosecant x. We want to change them in terms of sine x and cosine x, generally. Again, there are exceptions, but these four rules generally have helped me when solving identities. Okay, so now let's go through some common identities. These are going to be helpful when solving more complex identities, which we will get to later on in this video. I'll focus on examples first. But one of our first common identities is sine squared x plus cosine squared x equals 1. You can rearrange the identities so that it's 1 minus sine squared x equals cosine squared x, or 1 minus cosine squared x equals sine x. You just got this from just rearranging this, right? Okay, another identity we have is that tangent x is equal to sine x or cosine x. Then we have cotangent x is equal to cosine x over sine x, which makes sense because cotangent is the reciprocal of sine. And we have cosecant x, which is equal to 1 over sine x. And then we have secant x, which is equal to 1 over cosine x. Alright, so let's get into our first example here. Here we have 1 plus cosine x is equal to sine squared x divided by 1 minus cosine x. We want to prove that this identity is true, so in essence we want to prove the left side is equal to the right side. Okay, so this side is more complex, in my opinion, right? Because it's a fraction. If I'm done with fraction, it's good to reason right side is more complicated, and I want to simplify the right side. So what I'm going to do is I'm going to start off by simplifying this sin squared x. I'm going to sub in 1 minus cosine squared x is equal to sin squared x. Alright, again I'm leaving the left side alone for now. So when I do that, I get 1 minus cosine squared x over 1 minus cosine x. Now that I have this, again, keeping my left side the same, I'm actually going to factor my numerator, my 1 minus cosine squared x. I'm going to factor this like I would factor difference of squares. That's something you should be familiar with if you're taking great advanced functions, hopefully. And when I do that, I get 1 minus cosine x, 1 plus cosine x. Again, I'm going to sub that in for my numerator. So I get 1 minus cosine x, 1 plus cosine x. Again, that's divided by 1 minus cosine x. Okay, so now that I got this, what I'm going to do on the right side is I'm actually going to cancel this term on the bottom with this term on the top. And then when I do that, I get 1 plus cosine x is equal to 1 plus cosine x. So we can see now that my left side equals my right side, and therefore I have proved my identity. Okay, so now let's move on to our next example. Here we have sine pi plus x is equal to negative sine x. Alright, and to simplify this, we're going to want to look, not simplify, but to prove that our left side is equal to our right side, we're going to need to simplify our left side, right? Because this is more complicated. Alright, so what I'm going to do to actually simplify this left side is I'm going to use our compound angle formulas. This is something you should be familiar with from earlier on in this chapter, later on in advanced functions. So basically, if you don't remember that though, the compound angle formula for this is sine x, and then it would be cosine, or let me write this out generally. The general compound angle formula would be sine x plus y equals sine x cosine y plus sine y cosine x. So we're going to apply this general formula to our sine pi plus x. Alright, so let's just put this off in the red brackets as like a little bit of an aside. Okay, so back to our identity. If we use this, we get sine pi cosine x, and then we get plus cosine pi sine x. Again, keeping our right side the same with the sine x. Alright, if we were to evaluate this, sine pi has a value of 0, so this whole term cancels. Whereas cosine pi has a value of negative 1, so it's going to end up being negative 1 times sine x, which is going to give us negative sine x, which is also equal to the right side, which is negative sine x. Therefore, we have proven that this identity is true, and then the left side equals negative sine. Alright, so next identity is sine 2x over 1 minus cosine 2x equals 2 cosecant 2x minus tangent x. This is a little more complex of a problem. We're going to actually have to work on both sides, because both sides are pretty complex. Again, we have the ultimate goal of proving that the left side is equal to the right side. Okay, so what I'm going to do here first is I'm going to expand the numerator on the left side. We should know from our double angle portion of this course that sine 2x is equal to 2 sine x cosine x, so I'm going to apply that. So I get 2 sine x cosine x, and I'm also going to apply the idea that we have cosine x, sine squared x is equal to 1 minus sine squared x. So I'm going to apply that to our denominator and get 1 minus actually, my apologies, I'm going to apply the identity that cosine 2x is equal to 1 minus 2 sine squared x. Is reading the wrong note page. So 1 minus 2 sine squared x. Right, dealing with my right side, I'm going to express this as 1 over sine 2x. I can do that because not 1 over 2 over sine 2x, because for something it's reciprocal of sine. And then I'm going to say minus sine x over cosine x, because it's expressed tangent like that. And I'm going to expand the denominator on the right side and the left side. So cosine x, cosine x, over 1 minus 1, and then there's a cancel. And then I'll have 2 sine square root of x. Okay. Then take keep my right side the same thing around, just because I don't want too many things going on at once, but you could definitely keep this in one step. Alright, so now I can cancel out this 2 and 1 of the sines. So on the left side I'm left with cosine x over sine x. Right? That's very simple. This would just be cotangent. But now I want to work on my right side. I'm going to want to make a common denominator. So to do that, I'm going to expand this sine to x. I'm going to write this as 2 sine x cosine x. And then I'm going to make a common denominator with cosine x. For doing that, I get 1 minus sine x. And then times sine x over sine x cosine x. Should have showed that I would have crossed out these 2's. That's why I can do that. So I get cosine x over sine x equals 1 minus sine x squared over sine x cosine x. I'm going to use for my numerator the identity of 1 minus sine squared x equals cosine squared x. So if I plug that in, I get cosine squared cosine x over sine x equals cosine squared x over sine x cosine x. And cancel cosines, then I'm left with cosine x over sine x equals cosine x over sine x is cotangent x equals cotangent x. So my left side equals my right side. I have to prove it as 11. Okay, so that's it for this video. I'm probably going to post another video going over more examples, because I think that practice really does make perfect when it comes to this. Plus I have some identities on my note sheet that I can get to. So keep your eyes open for that. Again, if you have any questions, please feel free to comment below. And if not, thanks for watching this video.